Okay, a very good morning, dear students. And today we will be starting with the UML diagrams. We have seen in our previous lectures the building blocks of UML, which constitutes of the things, relationship, and the third is the diagrams. So now we have seen that the structural things, the behavioral things, the grouping things, and the relationships that we have studied, we need to apply now into the diagrams. So what are these diagrams? This diagram, basically, UML is a graphical language. As you are studying C programming, as you are studying Java programming, and for that you require to learn various syntaxes, you learn to understand the declarations, and you learn to understand how to write the statements and how to do the error handling, right? In the same way, UML is a graphical language. And in order to do this language, you need to understand what constitutes the language. And we have seen the building blocks that make this diagrams. Okay. So these diagrams are basically the graphical representation of the model. Now, this model is the system model. The system model can be a software model or it can be a hardware model, that is non-software or a semi one. Okay, so primarily with the graphical notations, we are going to design the blueprint for a model, which may be a software or a non-software. Now, this is basically represented as a connected graph. Okay, so when you see any particular diagram which belongs to UML, you will see it as a connected graph, and a graph like what? Vertices. Obviously, we know that graph is made up of vertices and edges. So these vertices are nothing but the things. The things means the structural things or the behavioral things, and the edges, that is the arcs, are shown through relationship. So this vertices, that is the things, can be the component diagram, can be the components, can be the packages, can be the nodes, can be the classes, can be the objects or the interfaces. Whereas the arcs, that are the relationship, can be association, dependency, generalization, realization, and so on. Okay, so when we are talking about this graphical notation, it's like a connected graph of things and relationship. So UML includes 9 diagrams. Okay, so there are 9 diagrams in UML which we will be learning and exploring. So each of this capturing a different dimension of the software system architecture. So why there is a requirement of 9 diagrams? There is a requirement of 9 diagrams because of the several dimensions. Some dimensions capture the static view, some capture the dynamic view, some capture the functional. Okay, so based on that, we have the 9 diagrams which capture the different dimensions. Now, we will be understanding. So, what are these 9 diagrams? First, I'll list out these 9 diagrams as you can see on the slide. The first is the class diagram, the object diagram, the use case diagram, the sequence diagram, the collaboration diagram, state chart diagram, activity diagram, component diagram, and deployment diagram. So these are the 9 names of the 9 diagrams that are present in UML. So now we will have a short definition of each of these diagrams. So moving ahead, first, that is the class diagram. So what is a class diagram? The most common diagram that is found in object-oriented analysis and design. Okay, so it is a most common. So you go to databases, okay, you have this class diagram, you have object diagram. So it is one of the most common diagrams you found in OMD, okay, and you found it also in databases. And what does it show? It shows a set of classes, interfaces, collaboration, and their relationship. Class diagram models the static view of the system. So it actually models the structural aspect of a system. Okay, and what we have already seen in our previous lecture. So when we say about structural things means the classes, interfaces, collaboration, and the relationship between them. So the relationship can be a simple association, it can be dependency, it can be generalization, or it can be realization. Okay, so class diagram models the static view of the system. The next diagram, object diagram. So object diagram is also a very common diagram. And what is object diagram? So we know that an object is an instance of a class, right? So a snapshot of the class diagram, okay, models the instances of things contained in a class diagram. So actually, the moment the class gets the value, okay, it becomes the object diagram. So if it is a class of people and in that people you have name, the moment that name is with equated with Dipali, okay, it becomes an object diagram because a snapshot of the class diagram, it models the instance of things contained in a class diagram. Actually, it becomes the, it's like a blueprint, okay, both these diagrams. Now, moving ahead, use case diagram. There is not much difference between a class diagram and object diagram. The conventions are same. Only the object diagram is an instance of that class diagram. Okay, when it gets the value. Now, moving ahead, the use case diagram. The use case diagram shows a set of use cases. Now, what is the use cases? Set of use cases means set of functionalities performed by the system. Functionalities like if you go to railway reservation and you want to perform the action of booking a ticket. So first, if you are a new user anywhere online now, login is the first functionality. Then authentication happens. You get an OTP, right? Once the OTP is sent, it is confirmed that this email ID, phone number, and the person is you. Then you have the form filling, that is searching availability of trains, right? Then based on your requirements you book it, then finalize it, and then the ticket is issued. So all these are functionalities, and this set of functionalities are shown through use cases. Okay, so what is there in the use case? There are actually the actors, that is the people involved, the people who interact with the system, okay, and their relationship. So the use case diagram models what the system is expected to do. So it is one of the most important diagram. See, object and class diagrams are the static view, but here in the use case, actually what the system is expected to do, first it is expected to authenticate. First it is expected that the user should log in, then authentication, then registration, then form filling, then booking. So all this is what the system is expected to do, and this is captured through the use case diagram. Okay, so what is present in the use case diagram? Actors. So actors, who are these actors? Actors means the people, obviously. See, now one thing I'll tell you, whatever is present in the class diagram is reflected in the object diagram. Whatever is there in the class diagram, okay, those classes, those people, those things, okay, will be present in the use case diagram. You cannot have such thing like one class is there and that class like interaction is not present or not visible in use case diagram. ऐसा बिल्कुल नहीं हो सकता. It is synchronous. Okay, so if at all you are showing one functionality login, and here in the class diagram you do not have anything in with related to the database of login, then your diagram is wrong. I'm understanding this is a self check. Means if you are specifying a particular class, if you are specifying certain things in the class, and or else if you are specifying some functionalities, some actors in the class, those have to be there in the class diagram and vice versa. एक में है, एक में नहीं है, एक में कुछ भी सेंस नहीं आ रहा है, मींस कोई क्लास का संबंध नहीं है फिर भी वो क्लास दिख रहा है यूज केस डायग्राम में, ऐसा पॉसिबल नहीं है. कहीं ना कहीं तो वो रिफ्लेक्ट होना चाहिए. अगर यूज केस लॉगिन है तो लॉगिन से रिलेटेड जो भी डेटाबेसेस के क्लासेस है वो क्लास डायग्राम में होने ही चाहिए. You cannot, and this is how the paper evaluators, the people who validate or accept or approve the system designs, cross check it. Means there has to be consistency. Okay, coherency in all the diagrams. Now, so I hope use case diagram is clear. So use case diagram actually shows the set of use cases, that is the functionalities that are performed by the system. Okay, the actors, typically people, system that interact with the system in the problem domain, their relationship. Further, models what the system is expected to do. Now, the next diagram, that is the sequence diagram. So what is the sequence? As the name suggests, sequence is how we have, like if you see, if you log in today for the lecture sessions, you have a sequence of lectures, right? Ki first this lecture, then this lecture, then this lecture. Is it that you sleep and the order is reversed? No, you get up, you have your tea, you have your morning activities, then you sit for lecture, you log in, right? Then you have the first lecture, then you have the second lecture, and so on, and the end of the day. Then finally, after the college session is over, you go on with your routine activities or some household activities, as we all are in lockdown. So what is this? This is actually how we operate, how everything works, like one after the other. And this is very important. Okay, see, obviously the system, there is going, when we are going to program or when we are going to design the system, कुछ flow होगा, कुछ connection होगा. ऐसे नहीं है कि अगर तुमको टिकट बुक करना है रेलवे का, विदाउट लॉग इन और विदाउट रजिस्ट्रेशन, तुम्हारा अकाउंट ही नहीं है, तुम बुक कर सकते हो क्या? आई एम नॉट टॉकिंग अबाउट गेस्ट लॉग इन. ओके, आई एम नॉट टॉकिंग अबाउट गेस्ट लॉग इन, पर यू हैव टू गो, लाइक बुक करके तुम लॉग इन करते हो क्या? नो, you have to do the login. Okay, you have to do the sequence and follow the flow, without which you cannot go for it. Okay, so I hope you are able to understand. When I say sequence diagram means जो हमारे दिन में हम एक के बाद एक sequence करते हैं, तो sequence diagram में क्या होगा? Obviously, for a particular software model, the flow of control by time, okay, ordering. So it depicts the interaction between various objects by the message passed with a temporal dimension to it. That is the time dimension to it. Like first students ने log in किया, फिर madam ने accept किया. ऐसे हो सकता है क्या? Students are attending the lecture और फिर madam accept कर रही है request? No. Time is there allotted, right? Now lecture start हुआ, फिर भी some students are entering, so I'm accepting them. But those are getting accepted at the different time interval, means lecture चालू होने के बाद they are being accepted, right? See, अभी भी एक student Pooja Sawant has joined. So I accepted. Now, can she be permanently in and the lecture starts? ऐसे नहीं होता है. So when we are drawing the sequence diagram, it actually models the flow of control. Means how is the control going from and how it is executing between the different actors. Like now, I am the object, that is, I'm a faculty and you are belonging to the student class, right? So the student is sending me a request, I am accepting it, then the student is joining the session, the student is attending the session, and then the student will log out. So ये sequence of events है, right? The sequence of events are with respect to time. So this basically models the flow of control by time ordering, depicts the interaction between various objects by messages passed with a temporal dimension to it. Okay, so the collaboration diagram is the next diagram. As we have seen, collaboration is something which we work together. When I was explaining the aspect of collaboration things, we have seen that collaboration, without collaboration, like human cooperation, nothing works on. And when there is a collaboration, there is an interaction between the objects. Okay. However, this is without the temporal dimension. So it temporal means time aspect is not there. Like just now, if you want to model the sequence diagram, there is a time factor. Ki chronology is there. फर्स्ट ये हुआ, उसके बाद ये हुआ, उसके बाद ये हुआ. बट व्हेन वी आर शोइंग कोलैबोरेशन, जैसे कि अगर हमको प्रोजेक्ट आइडिया प्रोजेक्ट हमारा प्रेजेंटेशन जो कंपटीशन था, इफ वी वांट टू शो कोलैबोरेशन, वो टाइम के बेसिस पे था क्या? नो, इट वाज नॉट टेम्परल. आई एम टॉकिंग अबाउट द collaboration diagram. So collaboration was without the temporal dimension. Temporal is time dimension. कि faculty interacted with student, the class coordinator interacted with the team leaders collaborated with their teams in return, then the coordinators collaborated with the faculty for event organizing, and so on. So this was, if I want to show it into a diagram, it is not I'm going to show one after the other. एक के बाद एक नहीं आएगा. It is going to be just an interaction. Okay, merely the messages passed between objects. Ki faculty assigned this task, then the class coordinator, the team leaders, and the team members interacted with the team leaders, right? Then the coordinator. So this will be modeled. So this is actually the collaboration diagram. So collaboration diagram, it models the interaction between the objects. So it is a different aspect with respect to the class diagram. Class diagram is capturing the static view of the system, whereas with respect to the collaboration diagram, there is an interaction which is being shown in the objects, and that too without the time dimension. Okay. So here, the messages are passed between the objects that are shown through the relationship. So the next diagram is state chart diagram. I have already told you that whenever we talk about any object, an object is what? Object is an instance of a class, right? So object kya hota hai? It's an instance of a class. So object like human being is an object. So it, since the birth of this object, okay, like object बनने से तो object destroy होने तक, okay, it goes through different phases, it goes through different stages, right? We human beings, we are, when our parents have given us birth, okay, we are in the baby phase. After baby, then we are child, then we are teenager, then we are adult, okay, then we are mature, and then we are old, and then death. So even the human life, the, you must have seen the caterpillar, studied the butterfly life cycle, the caterpillar, cocoon, larva, right? So what is this all? It goes through different stages, it goes through different phases. And this is what is shown through the state chart diagram. Okay, the state chart diagram shows different state machines and the events that lead to each of these states. Okay, so now for simple, consider the on and off of light glowing. Okay, till you press the button, it is off. The moment you press it on, okay, the bulb glows. The bulb keeps on glowing till you press off. Okay, so there are some external actions which make the particular, initially it was off, right? Now it is on, the light is there. So same about the fan. So initially it is idle, then it is rotating, and then you get the air, right? So you off it, the fan stops working. So the state chart diagram shows the different state machines and events that lead to each of these state machines. Okay, so the state chart diagram shows the flow of control from one state to other, and this flow of control from one state to other is triggered by an external event. Like consider the example of your phone, old phone, और smartphone भी ले सकते हो आप. So old phone जो कि ट्रिंग ट्रिंग बजता था. So what was it? First it was idle. Okay, the moment you hold your the receiver, you hear a dial tone, right? You hear a dial tone and then you press the numbers, like you dial the numbers. So you keep on dialing. So first from the idle state, then you are going to the dialing state. After dialing, there is a ringing state. अगर रिंग हो रहा है, अगर लाइन क्लियर है तो कनेक्ट होगा, then the communication will start, and then the communication will be stopped, and again you will hang down the phone. Okay, so this is the states what I am trying to show of the phone ringing. Okay, so phone ring ho raha hai, and see, everything is triggered. So ऐसे नहीं हो सकता, communication without connecting नहीं होता है. So उसके लिए पहले रिंग बजना पड़ता है. रिंग बजने से पहले, रिंग कब बजेगा? व्हेन यू आर डायलिंग द नंबर्स. और डायल कब करोगे? जब तुम आइडल स्टेट से उसको उठाओगे और तुमको अगर रिंगिंग टोन सुनाई देती है तो तुम्हारा फोन चालू है. अगर एक जमाना था वो पूछते थे रिंग टोन बज रही है, और कंटिन्यूअस बीएसएनएल के फोन्स पे था. ओके, और अगर नहीं है तो फोन डेड हो गया है, ऐसे बोलते थे, कंप्लेंट करो. So state diagram shows different state machines and events that lead to each of these state machines, and state chart diagram shows the flow of control from one state to other. I hope तो हर एक एस्पेक्ट, अभी जो ये आइडल एस्पेक्ट था, ये कोलैबोरेशन वाला एस्पेक्ट था, सारी चीजें ऑब्जेक्ट और क्लास डायग्राम में नहीं आती है। हर एक एस्पेक्ट दिखाने के लिए मींस अभी जैसे कि हमने बात किया फोन रिंगिंग का, तो फोन रिंगिंग में भी अगर इसको क्लास डायग्राम में डिपिक्ट करना है तो फोन रहेगा। ओके, द टेलीफोन नंबर, यूजर, एड्रेस, कब लिया, कब से स्टार्ट हुआ, उसके बाद यूजर्स रहेगा, फिर डायरेक्टरी रहेगा, ऐसे क्लासेस रहेंगे और यूज केसेस भी, रजिस्टरिंग द नंबर्स। तो एक ही सिस्टम के ये सारे डायग्राम्स बनते ही बनते हैं। कुछ स्टूडेंट्स को कंफ्यूजन रहता है कि मैडम हमारे सिस्टम में ये डायग्राम नहीं आएगा, ये डायग्राम नहीं आएगा। ऐसे पॉसिबल ही नहीं है। जो सिस्टम है तुम्हारा, सॉफ्टवेयर हो या नॉन सॉफ्टवेयर हो या सेमी हो, सारे डायग्राम्स आएंगे, बिकॉज हर एक एस्पेक्ट का कैप्चरिंग हम यूएमएल से कर रहे हैं। आई होप यू आर एबल टू अंडरस्टैंड व्हाट आई एम एक्सप्लेनिंग। आई जस्ट गिव यू एन ओवरव्यू ऑफ दी 6 डायग्राम्स नाउ, कि क्लास डायग्राम के बारे में बात किया हमने, इट वाज स्टैटिक व्यू, राइट? ऑब्जेक्ट इज इंस्टेंस। उसके बाद वी सॉ यूज केस विच इज रिलेटेड टू द फंक्शनैलिटीज, की व्हाट द सिस्टम इज गोइंग टू डू। उसके बाद सीक्वेंस, कैसे व्हाट इट इज गोइंग टू डू हमको पता चला, रिजर्वेशन करने वाला है, राइट? लॉग इन करेगा, रजिस्ट्रेशन करेगा, फिर बुकिंग करेगा, पर सीक्वेंस कब कैसा है इसका, पहले रजिस्ट्रेशन करेगा या फिर पहले बुकिंग करेगा? आपको भी क्वेश्चंस पढ़ते हैं ना कि मैडम हमको पहले ये करना है या पहले वो करना है। एक सीक्वेंस होता है कि तुमको पहले पढ़ना है, फिर सबमिट करना है, फिर ये क्लिक करना है। बहुत सारे स्टूडेंट्स अगर जब जो फर्स्ट टाइम फॉर्म भरते हैं या फिर कोई प्रोसीजर फॉलो करते हैं तो नहीं पता होता है, बिकॉज सीक्वेंस नहीं पता है, पता होता है क्या करना है, राइट, बट फ्लो ऑफ इवेंट्स नहीं पता होता है। तो सीक्वेंस डायग्राम वो कैप्चर करता है और फिर कोलैबोरेशन, इंटरेक्शन दिखाता है इन सब चीजों में। और स्टेट डायग्राम लाइक पहले आइडल थे, उसके बाद कुछ कर रहे हैं, उसके बाद फिर से बंद हो गया, तो ये जो है ये स्टेट डायग्राम कैप्चर करता है। ओके, सो वी नाउ गो टू द नेक्स्ट डायग्राम। अब सबसे इंपॉर्टेंट डायग्राम्स है एक्टिविटी डायग्राम। तो एक्टिविटी एज द नेम सजेस्ट, कि एक्टिविटी कर क्या रहे हो, ओके, व्हाट इज going on. So this basically shows the flow from activity to activity. So what is this activity now? It is an activity is an ongoing non-atomic execution within a state machine. Okay, अभी तुम एक स्टेट में हो, राइट? अभी डायलिंग है, तो यू आर प्रेसिंग द नंबर्स, यू आर प्रेसिंग द नंबर्स, ओके। उसके बाद यू आर कम्युनिकेटिंग, तो यू आर टॉकिंग। तो विद इन द स्टेट आपकी क्या एक्टिविटी चल रही है अभी? फॉर एग्जाम्पल आई एम जस्ट टेलिंग यू स्टूडेंट्स, ओके, ऑल द स्टूडेंट्स जो भी अभी लेक्चर में है, अभी वो कौन से स्टेट में है? कैन समवन आंसर दिस क्वेश्चन? अभिषेक, द स्टूडेंट्स, आई जस्ट आस्क्ड वन एग्जांपल।
Learning. In learning mode में.
या करेक्ट, सो दे आर अटेंडिंग द सेशन, राइट? तो उनका स्टेट क्या है? अटेंडिंग लेक्चर, राइट? बट अगर अटेंडिंग लेक्चर के अंदर क्या एक्टिविटी चल रहा है? दे मे बी लिसनिंग, दे मे बी नोट टेकिंग, दे मे बी कैप्चरिंग द स्क्रीनशॉट्स, right? Or they may be drawing what is present on the slide, or there may be some students who are doing multiple tasks like journal लिख रहे हो, या फिर WhatsApp पे हो, या फिर XYZ। So ये स्टेट में, जो स्टेट है तुम्हारा, वो स्टेट के अंदर देर आर सम थिंग्स दैट आर गोइंग ऑन, ओके, एंड दोज आर नॉन एटॉमिक एग्जीक्यूशंस एंड दे आर विद इन द स्टेट मशीन। So this is basically the activity diagram. So I hope you have got this what I'm trying to say. Now, एक state, everyone, like I am in the teaching state. Now, when I am in the teaching state, now what did I do? There was one student, okay, who entered right now. So I accepted that student. So that was one of the non-atomic activity that I did while I was in the state of teaching. Are you understanding? So it is a part of what I am doing right now in that state, and I'm also doing some mini activities within that state. Okay, and this gets captured in the activity diagram. Now, the last two diagrams. Now, the last two diagrams, that is the component diagram and the deployment diagram. Now, most of the students find this difficult to diagram. ओके इसका डायग्राम कैसे निकालना है, क्या निकालना है, कंपोनेंट. सो बेसिकली इट इज, इफ यू आस्क मी, इट इज द इजीएस्ट वन. ओके कंपोनेंट क्या है? कंपोनेंट तुम्हारे सिस्टम की, इट शोज द फिजिकल पैकेजिंग ऑफ अ सॉफ्टवेयर इन टर्म्स ऑफ कंपोनेंट्स एंड द डिपेंडेंसीज बिटवीन देम. तो फिजिकल पैकेजिंग ऑफ द सॉफ्टवेयर जो भी तुम्हारा है, लाइक यस्टरडे आई टोल्ड यू, when we talk about package, okay, so we see that अगर तुम ऑर्डर करते हो कुछ भी ऑनलाइन स्विगी से, या फिर इफ यू आर गोइंग फॉर डोमिनोज पिज्जा, सो यू हैव अ पैकेज, राइट? कि ये मील प्लस दिस मील यू गेट अ कॉम्बो पैक. तो एक्चुअली इट्स अ पैकेज, सो इट्स अ कंपोनेंट. ओके कहीं पे स्पेसिफिकली मेंशन नहीं है. तो it actually shows the physical packaging of software in terms of components and the dependencies between them. तो ये बहुत इंपॉर्टेंट है. तो कंपोनेंट डायग्राम जैसे कि हमने व्हेन वी वर टॉकिंग अबाउट द प्रोजेक्ट आइडिया प्रोजेक्ट कंपटीशन, that time also I said that the PPTs, those are the components. Okay, the PPTs are the components, then the small extension files, okay, in your program, the header files, the C files, the parsing files, the linking files, all these are the physical files which you can see. Okay, and those are the parts of the software. So component diagram also we'll see in detail and the notations for it. And the last diagram, that is called the deployment diagram. Now, deployment diagram actually shows the configuration of processing nodes at runtime and the components that live on them. Okay, so this is one of the most important things. So deployment diagram shows the configuration of processing the nodes at runtime and the components that live on them. So abhi we are talking through the cell phone. So cell phone, and where is the cell phone connected to? It's a actually a device only, right? Then I'm using internet, I'm using modem. So internet I cannot show, right? There's a modem, there's a server, I'm using some server, I'm using some services which are provided by the service providers, right? Then I'm using my laptop. So without laptop I cannot. So this is a node actually. So without laptop, without any device, can I get connected to you? No. The software obviously is going to get deployed on something which is having a physical reality, राइट? कोई भी सॉफ्टवेयर है कहीं पे तो डिप्लॉय होगा, कहीं पे क्लाउड पे होगा, सर्वर पे होगा, डेटाबेस कहीं पे तो होगा, राइट? तो ये जो फिजिकल एस्पेक्ट है ऑफ द सिस्टम that are deployed somewhere in reality are actually shown as the processing nodes at runtime and the components that live on them. अभी components that live on them like C files उसी पे store है, header files उसी पे store है, पूरा सॉफ्टवेयर का exe जो है उसी पे store है. हम बस कॉल कर रहे हैं और रन कर रहे हैं और डेटा एंटर कर रहे हैं. फिर अगेन वी आर गेटिंग कनेक्टेड टू द बैक एंड सर्वर, बैक एंड डेटाबेस, फ्रंट एंड. तो ये सब कहाँ पे डिप्लॉय हो रहा है? कहीं पे तो हो रहा है, फिजिकल स्ट्रक्चर है इसका, हवा में नहीं हो रहा है, राइट? तो वो कैसे दिखाएंगे? तो ऑब्वियसली दैट इज गोइंग टू बी शोन थ्रू डिप्लॉयमेंट डायग्राम. Okay, so the deployment diagram shows the configuration of processing nodes at runtime and components that live on them. So now I have given you a brief overview of all the 9 diagrams that we are going to study in detail one by one in the subsequent lectures. Okay, so now if you see this diagram, the dimensions we have been talking about, right? This 9 diagrams ki ek diagram ki kya zarurat hai? 9 diagrams, like ek diagram क्यों नहीं है, 9 diagrams क्यों है? Because we have seen very first, it captures the different dimension of the system under study. Okay, and what are these dimensions now? So as we have already seen कि the dimensions जो है वो software होते हैं. Okay, so dimensions जो है वो structural view है, behavioral view है, implementation view है, and environment view है, right? So this 9 diagram, see the class and the object diagram. जब भी आपको किसी system का structural view दिखाना है तो कौन सा diagram होना चाहिए? Class diagram and object diagram. Now, dear students, very what you can say, be attentive and listen. कि 9 diagrams जो है उसका बाइफ्रिकेशन, उसका डिवीजन और उसका रादर उसका क्लासिफिकेशन कैसे हुआ है बेस्ड ऑन डायमेंशंस. तो डिफरेंट डायमेंशंस कंसिडर कर किया है हमने यूएमएल में, राइट? तो कौन से डायमेंशंस है वो? स्ट्रक्चरल व्यू है, बिहेवियरल व्यू है, इम्प्लीमेंटेशन व्यू है, एनवायरमेंट व्यू है। ओके, तो जब स्ट्रक्चरल व्यू को कैप्चर करना है तो कौन सा डायग्राम है? क्लास डायग्राम, ऑब्जेक्ट डायग्राम। जब बिहेवियर को स्टडी करना है वो सिस्टम का, तो कौन से डायग्राम्स है? सीक्वेंस डायग्राम, कोलैबोरेशन डायग्राम, स्टेट चार्ट डायग्राम, एक्टिविटी डायग्राम। सो 6 डायग्राम्स यहाँ पे होंगे। ओके, so you cannot have, you activity diagram will not show you the structural aspect, it will show you the behavioral one. Okay, then implementation view हमको कहां से पता चलेगा? कंपोनेंट डायग्राम से। और डिप्लॉयमेंट डायग्राम इज द एनवायरमेंटल व्यू। एंड यूजर व्यू जो है, जो सबसे इंपॉर्टेंट है, वो कैसे कैप्चर होगा? वो यूज केस से। बिकॉज यूज केस क्या बताता है? यूज केस बताता है फंक्शनैलिटीज को, बिहेवियरल डायग्राम्स बताते हैं उसके एक्शंस को, कंपोनेंट बताता है उसके कंपोनेंट्स जो उसको बनाता है। सो यूजर व्यू जो है वो यूज केस डायग्राम से कैप्चर होता है। I repeat once again, there are basically 5 views or 5 dimensions of software architecture. So they are structural, implementational, behavioral, user and environmental view. So when we want to capture the structural, or when we want to draw, or we want to have a graphical notation of the structural view of the system, we go for class diagrams, object diagrams. When we want to show the behavioral view, we draw sequence diagram, collaboration diagram, state chart diagram, activity diagram. When we want to understand the implementation view, we see and draw the component diagram. And when we want to understand the environmental view, we draw the deployment diagram. Use case diagrams are drawn to understand the user view. Okay. And then what are the rules for this? Okay. So moving ahead, like when we have seen that there are some rules, then there are some mechanisms. Okay. So common mechanisms. Just a moment, dear students. So we have seen after this diagrams, the next aspect, I hope these diagrams are clear to all. The next aspect is the rules, which I'll be covering now immediately so that we complete with this. So rules means what? They actually specify a well-formed model should look like. Okay, the UML has semantic rules for names. Okay, see when we say we want to draw this diagrams, तो कैसे भी हम diagram नहीं draw कर सकते, right? हर एक का notations है, कैसे होंगे, कहाँ पे होंगे, तो all is decided. आपको अगर syntax में, अगर do you use curly brackets anywhere for declaration? No. Do you use colon instead of semicolon at the end of printf statement? No. Do you use a single quote to print? No. Printf we use double quotes, right? So these are the rules, these are the semantic rules which the lexer, parser understands and the compiler understands. If it is not, there is some mistake, like semicolon ke jagah colon diya hai, to compiler will give an error while compiling, right? So the UML also has semantic rules for declaring the names, the scope, the visibility, the integrity, and execution. Okay, then the common mechanisms. So what are these common mechanisms? These are mechanisms / elements that apply consistently throughout the language. Means this is a programming language, right? It's a graphical language, like you can consider it. It's not a program नहीं बनाते हम UML से, but ये language है, और language के ये जो common mechanisms है, ये consistently they are throughout the entire system. सब system change है, ऐसे नहीं कि आज मैंने एक diagram draw किया, मेरे conventions अलग है, तुम्हारे conventions अलग है, ऐसे नहीं हो सकता. ओके, ये जो भी UML, अगर मैं बोल रही हूँ, अगर मेरा क्लास एक मैं ड्रॉ करती हूँ पेंटागन, सो पेंटागन कैन नॉट बी अ क्लास. अगर मुझे कुछ दिखाना है, स्पेसिफिकेशंस करने हैं, मुझे कुछ अडॉर्नमेंट्स करने हैं, सो कॉमन डिविजन्स. ओके, सो वील टॉक अबाउट दिस. सो इट विल बी सेम, दे अप्लाई थ्रू आउट द लैंग्वेज एंड दे आर कॉमन टू ऑल, they do not change with person. Okay, so Mechanisms/elements that apply consistently throughout the language are specifications, adornments, and common division. Also, the extensibility mechanism. So now we'll see these adornments are nothing but notes. You have seen ना, एक नोट जैसे फ्लैप्ड ईयर वाला नोट था, हमने देखा था कि कुछ अगर मेंशन करना है, आई हैड गिवन द एग्जांपल ऑफ लॉगिन यूजर नेम पासवर्ड, पासवर्ड के लिए कन्वेंशंस अगर देने हैं तो यूज a combination of characters, कैपिटल लेटर एंड स्पेशल सिंबल्स, तो ये नोट है तो इसका सिंबल सेम रहेगा. ओके, एक्सटेंसिबिलिटी मैकेनिज्म्स में क्या है, स्टीरियोटाइप्स है, टैग्ड वैल्यूज है और constraints है, right? So add-on the model, that is enhance the model, add this the meaning and semantics to the element which pertains it. So what are notes? Key notes are the mechanisms provided by UML for adorning a model. They are graphical symbol to render constraints, comments. कि constraints क्या, validation, verification, checks. कि अगर यूजर नेम सिंपल हो तो ब्रेक हो जाएगा, तो कंस्ट्रेंट्स क्या है, कैपिटल लेटर यूज करो, स्पेशल सिंबल्स यूज करो. ओके, कमेंट्स, जो भी कमेंट्स है कि ऐसे करो वैसे करो. तो नोट्स एक ग्राफिकल सिंबल है. ओके, उसका सिंबल मैंने दिखाया आपको इट्स अ रेक्टेंगल विद अ फ्लैप्ड ईयर. ओके, उसको नोट बोलते हैं. अ नोट दैट रेंडर्स ओनली अ कमेंट, हैज नो सिमेंटिक इम्पैक्ट ऑन द एलिमेंट, इट इज एडोरिंग, at most adds meaning to it and provides guideline for implementation. Means जब भी कोई प्रोग्रामर लॉगिन का पेज डिजाइन करेगा तो वो वैलिडेशंस में ये देखेगा कि यूजर नेम और पासवर्ड के फिक्स कन्वेंशंस हो, डिटेलिंग हो. ऐसे ही नहीं कुछ भी दिया है तो एक्सेप्ट करो, नहीं चलेगा. तो और भी ऐसे हो सकता है कि कोई लोग यूजर नेम के लिए नंबर्स दे, फेक नेम दे, नहीं चलेगा. इट शुड बी फर्स्ट नेम, मिडिल नेम, सरनेम. ओके, कुछ कैरेक्टरिस्टिक्स है, स्टीरियोटाइप्स. जो स्टीरियोटाइप्स यहाँ पे मेंशन्ड है, these are actually used to create new building blocks from the existing block. Okay, so new building blocks are domain specific. A particular abstraction is marked as a stereotype, and this stereotype is then used as other places in the model to denote the associated abstraction. So stereotypes, how they are shown? They are shown through this notation: double opening arrow brackets. Okay, and what is the stereotype? It is written inside it. Tagged values. So tagged values used to add the information of element, not if instances. Stereotype help create new building blocks. Tagged values help create new attributes. Okay, they're commonly used to specify information relevant to code generation, configuration management, etc. And what is the notation for it? Curly brackets. Okay, so these what we are talking right now, दे आर फॉर डिटेलिंग. मीन्स अगर क्लास हो गया, रिलेशनशिप्स के नोटेशंस हो गए, यूज केस के नोटेशंस हो गए, और डिटेलिंग अगर कुछ करना है तो हाउ डू यू डू इट? यू डू इट थ्रू नोट्स, यू डू इट थ्रू स्टीरियोटाइप्स, यू डू इट थ्रू टैग्ड वैल्यूज. सो तीनों का नोटेशन क्या है? टैग्ड वैल्यूज का कर्ली ब्रेसेस है, स्टीरियोटाइप्स का डबल एरो ओपनिंग और क्लोज ब्रैकेट्स है. उसके बाद वी हैव सीन अडॉर्नमेंट्स, नोट्स का जो है वो फ्लैप्ड ईयर वाला है. Okay, or constraints. Abhi constraints, these are used to create rules for models, rules that impact the semantics of the model and specify conditions that must be met. Abhi kuch conditions hoti hai, right? Temperature itna ho to बंद करो माइक्रोवेव, राइट? ये ऑटोमेशन जो सिस्टम्स है, लाइक वॉशिंग मशीन का ऑटोमेशन है, एटीएम का ऑटोमेशन है. कंडीशंस, यूजर नेम पासवर्ड मैच किया तो मनी विड्रॉ, एक्सेप्ट. ओके, अगर नहीं हुआ तो रॉन्ग यूजर, forgot यूजर नेम पासवर्ड करो. सो ये सारे कंस्ट्रेंट्स है एंड दीज आर रूल्स टू मॉडल. सो the rules that impact the semantics of the model and specify conditions that must be met. So they can apply to any element in the model, attributes of the class, relationship, etc. So notation: incomplete, comma, disjoint, open and curly bracket. So this is the notation. So with respect to the first part of UML, we have seen that modeling, why modeling is essential. Modeling captures the system in its entirety along with the different dimensions of its complexity. ऐसे नहीं है कि जो सिस्टम तुम पढ़ रहे हो या फिर बनाने की कोशिश कर रहे हो एज एन इंजीनियर इजी हो, कॉम्प्लेक्स भी हो सकता है. बट सबसे इंपॉर्टेंट क्या है? उसकी हर एक डायमेंशंस को कैप्चर करना. और वो कैसे कर सकता है? प्रोग्रामिंग के हिसाब के लिए पहले उसका ग्राफिकल अंडरस्टैंडिंग हो, वो करता क्या है, ये पेन एंड पेपर से प्रेजेंट हो. सो facilitates quick and efficient analysis and design and helps communicate the overall system architecture ambiguously. उसके बाद we have seen the principles of modeling. Lay down that model must be well chosen. Model should encapsulate different granularities as in detailing. Model can make simplifying assumptions but not hide important facts. Means जो भी तुम्हारा सिस्टम है तुम ऐसे नहीं बना सकते, जो तुम्हारे पेपर पे मॉडल ड्रॉ है, जो ब्लूप्रिंट है, वो हाइड नहीं कर सकता कुछ भी. अगर वो हाइड है तो इट इज एब्सेंट फ्रॉम द सिस्टम, द प्रोग्रामर विल नॉट बी एबल टू डू इट. So no single model can capture all dimensions of complexity, and therefore we have different 9 diagrams. Okay, what is there in the diagram will be program. So UML is a language that helps analyze design solutions for software intensive system. It is developed by Booch, Romberg, and Jacobson at Rational Software, subsequently adopted as a standard by OMG in 1997. So it's a language for visualizing, specifying, constructing, document the artifacts of software system. I'm just going through a very quick recap as we have completed this part, this unit. So it's a modeling language and not a methodology or a process or a programming language, my dear students. It's a purely graphical language. So the conceptual model of UML comprises of building blocks of UML, its rules and certain common mechanisms that are applicable across the entire language. The building blocks comprises means we have seen that कि जो conceptual model है वो 3 चीजों का है, वो है building blocks, rules or common mechanisms, and this is applicable throughout the entire language. So building blocks comprise of things, इसमें structural है, behavioral है, grouping है, relationships, association, dependency, generalization, realization, diagrams जो कि 9 diagrams जो we have seen today. Then things are grouped into 4 categories as we have seen: structural, behavioral, grouping, and annotational. I've already discussed that. Structural things describe the static part of the model. There are 7 types: class, interface, collaboration, use case, active class, component. Behavioral describe the dynamic part of the model, and there are 2, that is interaction and state. Packages are included under grouping things and notes under annotational things. Relationship things link things to each other and are 4 types: dependency, association, generalization, and realization. Diagrams are essentially connected graphs. They are a set of vertices connected by arcs, which are equated with relationship. There are several diagrams, each capturing the different dimensionality and view of the system. So altogether, there are 9 diagrams: the class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, implementation diagram, and deployment diagram. So UML has semantic rules for names for classifiers, scope of these names, visibility of these names, integrity and execution of the model. Also, there are some common mechanisms that apply uniformly across the model, and those are for specification, common division, adornments, extensibility mechanisms. Notes are the most common adornments used, and they are add meaning to the classifier. Extensibility mechanisms include stereotypes, tagged values. So these are the references, and you all can go through it for detail. So I hope you have understood this session.